Hello, my name is Jörg Schober. I'm enterprise architect for artificial intelligence at OMV. And today I'm going to show you how we designed our generative AI platform, plus machine learning also, but mostly generative AI in a large industrial company like OMV. Oh, I think it stopped now. I think the battery is empty. Oh. Hello? Yeah. Yes. So, first of all, before I dive into the platform approach that we did, I want to set the stage a little bit and show you a little bit about OMV, because then you understand better our design decisions. So OMV is the largest industrial company in Austria. We are integrated chemicals, fuels and plastics company, let's say it like that. We operate all over the world. You don't need to focus on the colors here, but I want to show here that we have basically 4 very different business divisions, and that makes it very interesting. And that's also what it makes it interesting for me the most about these kind of companies, is that we have such a heterogeneous business model. So we do heavy industry, we do very complex geological engineering, we do chemical science, we have market trading, we have a full-fledged retail chain down to selling coffees in the fuel stations. Yeah, so you can see none of these business models are really digital, but all of them require digital platforms. And that leads me to our generative AI. What I wanted to show you here is how much demand we have from all our business units. We have 140 plus demands coming from our business only in the area of generative AI. We have 40 plus POCs, proof of concepts, and delivery projects running. We have 15 live generative AI use cases, specific use cases, and 11 products, generative AI products, that are serving multiple use cases at once. And that all we unified in one platform, published in one platform, which we call the AI Hub. Why did I show you these slides? I wanted to show you that you can imagine with such a high demand from business, it's very hard to scale. Yeah? And the platform approach, which I want to show you now, is our way of how we were able to scale on that big amount of demands. How do we do that? We basically start from use cases. We get use cases, we get demands from business, and what I as an architect, so what is my job in this role is, I have to analyze these use cases and see where we have reoccurring patterns. So where are different use cases that need the same thing? And then we build products out of these use cases. Products usually serve at least one use case, but in the best case, they serve multiple use cases. So if one use case needs in this case, it was analysis of tabular data, and basically analysis of Excel-style data. Yeah, we had 3 use cases that needed this, and so we delivered a building block and then a product which could cover all of these use cases at once. And that's how we then create our products, and we publish them in our AI platform. So in the end, we had a product that end users could use, where they could upload arbitrary tabular data and let it be processed by AI. So, so what is our approach for the platform? Our approach is we have we have multiple federated AI product development teams, which are served by one central platform team. The central platform team creates building blocks that are then used by the development teams to assemble AI products, so that they don't have to build it from scratch all the time. Then we have a central funnel where all of the demands from business come in. All of these 140 demands that you saw have to be somewhere managed in a backlog, so that we can see and we can judge, okay, these use cases make sense to implement. They have enough impact. They are not so. They are probably the data quality is good enough. The business case is existent. Yeah. And with all these metrics that we have there in this central pipeline funnel, we then decide which ones we are going to implement and who is going to do it. And then we have implemented a community of practice, which I also can recommend to all of you. Implement a community of practice where users can participate interested users, but also AI engineers, and can talk to each other, communicate with others, and exchange their experience and their ideas. Yeah, and the central platform team enables, as I said, enables the development teams to develop the AI products. How do we enable them? We have central documentation published, learning paths, design guidelines. We have all our reference architectures published centrally. So a reference architecture is a template of how a solution should look like. For example, if we have a chatbot with agentic tool calling, it has to look like this if we deploy it on our cloud platform. And it always looks the same. That makes it easy to operate, right? And we can also automate the instantiations of these tools. So it's a little bit scarier, no? But in the end, it's not so complex. This is how the platform is structured. So as you can see on the bottom, we have the data platform. We have a stable data platform with data products, where we have owners of the data products, and they guarantee that the data has enough quality. Because any AI solution that works with data, which is basically every AI solution, yeah, they are relying on qualitative data products. Then, on top of that, we have our building blocks, as I mentioned. The building blocks are the parts, the Lego blocks, basically, that we build our AI products with, So this is, for example, now our indexing building block, our AI core template, which takes care about chatbot conversations, which we use in many of these products. And on top of that, we have our AI products, which are assembled with the building blocks. This could be various types of products, chatbots, automations, batch processing, content generation services, and now also our agents. And all of these products are behind the API layer. So all of these AI products can be accessed via an API, which is very important. Now it's also MCP enabled, so you can access any of these products with an MCP, with the MCP protocol, so that we also enable them to be accessed via automated flow. And all of these products are then published. The ones that need a user interface are published in the AI Hub, which is a web application that we developed where we give access to all our employees, our end users that can access these products, where we have the access control, access to the products, where we have the documentation, the learning paths, and some guiding principles. So basically, this is how we do it, and this is how we develop these products. We have this, as I mentioned, we have this central AI platform team, which you see on the top here. They work with the huge AI use case backlog. They are responsible to identify the reoccurring patterns. Yeah? For example, AI solution needs a web scraper, another AI solution also needs a web scraper, so we develop a web scraper building block, which we can reuse then, which then the product development team, which is here on the bottom, is using to develop the AI products. Yeah? So there's also a feedback loop here, so if the product development team says, hey, we need an adaptation to an existing building block, or we need a new one, then there is a feedback to the central platform team to develop this building block. Yeah? And this is how you can scale. You need you don't need 100 developers, you need a central platform team, and the product development teams can also be external provided. Often, in our case, they are often external developers, right? So, then, for publishing the AI products, we have our OMV AI Hub, which is a web application, as I mentioned. On the left side, you can see this is from some time ago, but you can see some AI products that I personally have access to. We have our internal GPT version, which has our data behind. We have assistants that help you with translation, with the tabular data analyst that I mentioned, which can work with tabular AI data, and we have all our courses, our prompt library, our documentation, our guiding principles, all for the employees in one central access point. Because we saw, all of these AI agents are all over the place, all of these tools are all over the place, our internal employees got confused. They had no idea, we have here a copilot, here we have a ServiceNow assist, here we have that, here we have that. So we decided to centralize everything into one access point, because otherwise it was not possible to keep an oversight on all these AI products. Yeah, so we have also a mobile app, as you saw here, which we released lately. Good. This is an architecture of the AI Hub. Yeah, I just usually show it to scare audiences like you, but no. In the end, it's not so complex. You can see we have on the left side, we have a browser which accesses our AI Hub backend, and our AI Hub forwards the requests to the actual products that you have on the right side here. Yeah. So here we have, for example, a product which is a chatbot that runs on Microsoft Azure. This is in the governance of the product development team, right? The product development team is responsible to operate and assemble this infrastructure here on the right side for the chatbot. They get the reference architectures, they get a blueprint for that, they get our building blocks, but they are responsible to run it and assemble it. The platform team only takes care of developing these building blocks and templates, how they should look like, and for the AI Hub itself. These products on the right side can also be low-code products. We have now Microsoft Copilot Studio. Some of you might know it. We have UiPath, we have Databricks AI. We have a lot of low-code solutions that can also be published on the AI Hub. Yeah? And also we have other products that just are not chatbots, but other assistants that have forms, web forms. So we cover that all in one place. Some of the building blocks I want to show you that we have the AI Hub itself, which is the publishing, the web portal to access the building blocks. We have a core library that takes care of communicating with large language models, with embedding models, with re-rankers. We have our core bot template, which is basically a building block that covers everything from the conversation handling and the dialogue handling and the conversation history when you have a chatbot. We have content extractor building blocks that can extract content from files, from PDFs, from whatever PowerPoints, with image descriptions and all of this kind of stuff. We have AI indexer, which indexes this data into a vector databases and so on. Web scrapers, we have our reference architecture. So you see the platform team has a lot of building blocks that they have to manage. No? But in the end it pays off because you don't have to build the AI products them from scratch. You reuse the building blocks. That is the point. Some of the technologies we use, I mean, you know them anyway, large language models, embedding models, vector databases, re-rankers, document intelligence services, OCR, content extractions, and other services we are mostly on Microsoft, so other services that Microsoft provides via their Microsoft Azure Foundry services. Yes, so what I wanted to show you as a takeaway is the challenges that we are facing in such a large environment, such a heterogeneous environment with so many different business models. And what me personally as an architect, what challenges me the most is how to identify building blocks, how to keep an oversight of the 150 demands that business has, how do we identify the reoccurring patterns, right, in all of them. And then to decide, do we want to invest into building this? Do we want to invest into now building an AI web scraper? Or do we have something on the roadmap from our strategic partners like Microsoft or Google? Yeah? Are they building something for that? That's always a decision we have to take. When do we invest into building these building blocks? Yeah, and I think I have a minute left, that's good. Also then what is a major point is the life cycle management of these building blocks. You can imagine these building blocks are used in many AI products. You have to update them, and you have to roll these new versions of the building block out to the AI products. So it's also a very challenging task. And of course, also managing external development teams that are using your building blocks to develop AI solutions, it's also a challenge because you have to onboard them. My key takeaways from you, this is my last slide. A self-service platform approach for generative AI in a large enterprise is, in my opinion, the best way to scale, unless you have 200 developers or 100 using AI nowadays, yeah, but still. With a small central platform team, you can cover a lot and you can scale very well. create reference architectures for your solutions, for your reoccurring patterns. So these are templates how these AI solutions have to look like so that they are homogeneous in the end. Create building blocks, I mentioned that quite some times now, and evaluate carefully when to invest into new building blocks. Yes, and the central platform team here is plays the key role in your ability to scale. So that's my key takeaways. That's my LinkedIn. Happy to connect with you. Happy to talk with you later or online. So thank you very much.